This video will show the results of a demonstration session that was held on the 14th and 15th of April at IRT in Munich. The session brought together researchers from all of the project partners. During the session, the team were able to put the finishing touches to a first version demonstrator, which features delivery of two stereoscopic views over DVB-T and IP. The two views are synchronized with spatial audio, and then rendering is carried out on a stereoscopic display and on an 8 loudspeaker spatial audio system. Let's take a more detailed look at the demonstrator, starting with the content server. In this shot we can see a spectrum analyzer plus the screen of the content server, with DVB module readouts top left, peer-to-peer module top right, and security module bottom left. If we zoom out now, we can see the overall demonstrator setup, with from left to right the main server, the control and video rendering PC, and the audio rendering PC all present. We can now see the video rendering PC, which contains demuxing, decoding, video rendering modules and control modules. Two stereoscopic views are shown locally on the monitor, which are being streamed via DVB-T and IP. This is done to check that the video is being delivered correctly before connecting it to the stereoscopic display. Next we move along to the audio rendering PC. For audio rendering, 8 loudspeakers were used, and tests were carried out with decoding of differently compressed and formatted audio, including object-based audio, AC3 5.0 audio, and MPEG-1 Layer 2 stereo audio. Finally, let's examine the results of the demonstrator. The first version of the renderer has been configured to support multiple stereoscopic displays using either line-by-line output or side-by-side. This active stereo display requires side-by-side input, so this mode is chosen by the renderer. The setting is then changed on the 3D display to enable 3D viewing. We can now hear and see synchronized 3D audio and video being sent via DVB-T and IP. The first demonstrator will form the basis of our final demonstrator. It has enabled us to prove the system architecture concept. The next version of the demonstrator will see significant upgrades, including decoding and rendering of more views, more advanced content adaptation approaches. In addition to this, a significant number of tests will be conducted to validate and characterize the performance of the DIOMEDES system.